All right, let's try it again now that I got word back going. All right, so let's set this up. We have this as N, oh my goodness, sorry. N equals 285.88 grams. That was our molecular mass, divided by the mass of this, which we calculated to be 141.94. And we want the nearest whole number here. By the way, this is grams per mole. And the nearest whole number is obviously going to be 2. So that means that this formula, the P2O5, was reduced by a factor of 2, so that we can go through and we multiply this by a subscript of 2, all the subscripts. So that means the molecular formula was P4O10. So that's how you do that problem. And again, this formula here was the N equals M over E, where M is molecular and E is empirical mass. Okay. All right, so let's try a little longer one now. Okay, a compound consists of 6.98% carbon, 1.17% hydrogen, and 9.31% oxygen, and has a molar mass of 90.08 grams per mole. Determine the molecular formula. So on these ones, they're giving us percents, but we're going to assume the percents are out of 100 grams. So we can just make the percents. So I'm going to put this here. The percents are going to equal grams. So we're going to start out. We have 6.98 grams of carbon. We have 1.17 grams of hydrogen. And we have 9.31 grams of oxygen. Okay, so what we need to do at this point is you can't compare grams when it comes to elements. So you have to change it to moles. So how do we change from grams to moles? Do you guys remember? You look up on the periodic table and you look up their atomic mass. So to go for carbon, we have to divide by the mass of carbon, which is 12.01 grams. And we want to kind of get these to 2 decimal places too, so make sure you do that. And 1 mole of hydrogen is 1.01 grams, and I'll calculate these in a second. And 9.31 grams of oxygen, 1 mole of oxygen on the periodic table is 16.00 grams, or you could use 15.99, but that's annoying to me. Okay, so let me calculate these. Let's see, we have 6.98 divided by 12.01. That's 0.581. We'll do 3 decimal places. Okay, I know this one's going to be close to 1, but let's just see what it is. 1.17 divided by 1.01 is 1.158. Okay, and let's do this guy. It's going to be 0.5, but let's see what specifically. 9.31 divided by 16, 0.5819. So 0.582. Okay, so at this point, what you do, because now they're in moles, you can compare them to each other. So you're going to divide them all. The way we compare is divide them all by the smallest number of moles. So this 0.581 is the smallest, and we want the nearest whole number when we divide. So that's obviously 1. Let's just check this one, even though it looks, I don't need the right mole there. Let's just check it. So 1.158 divided by 0.581, and I get 2. Okay, and then obviously this is 1. Okay, so that means that this is giving us our empirical formula. Our empirical formula is C1, right, which don't we need to write the 1, H2O. So that's our empirical formula. Okay, you can tell it's empirical too because it's reduced. Now, it says, what's the molecular formula? So now we're going to go back and use that other equation we were using before, where we had that, oh, let me pick my pen again, where we had that N equals me, right? So it told us in the problem the mass of the molecular. What did it say? It's 90.08. Okay, so 90.08 goes here. Can we get a mass of this thing? Yes. Let's add the periodic table. So we have carbon's 12.01, plus each hydrogen's 1.01. So 1.01 times 2 plus oxygen 16. So that's 30.03. Okay, and if we divide those, the nearest whole number is 3. So that means if we take the CH2O and multiply that by 3, you're going to get C3H6O3. So that is the molecular formula. So that's pretty much as long as they'll get. And remember, I know I talked to some of you guys about the fact that what they use these type calculations for is it has to do with, if they're trying to figure out if we analyze a drug maybe that comes into the forensic lab and we're trying to figure out what it is, we compare it with the percent of the different elements that are in there to see if it's actually the substance. That's how some of the instrumentation works in the lab. All right, so let's take a look at this next one. And then the last one I'm going to have you do on your own, and maybe we'll do it in class on Thursday, if you guys remind me. Okay, example 3. The compound for ethylene glycol is often used as antifreeze. By the way, side note, antifreeze tastes sweet to cats, so it will kill them, so never leave it out because they like it and it will kill them instantly because they're so tiny, cats usually. It contains 38.7% carbon, 9.75% hydrogen, and the rest is oxygen. The molecular weight, and again, this is going to be the molar mass of ethylene glycol, is 62.07. What is the molecular formula? Okay, so we're going to do the 38.7, again, it's hard for me to write this pen, sorry, grams of carbon. Remember, assume the percent of grams. And we're going to convert that to moles. That's always the first step. I'm sorry, I really can't write with these pens. So if you are somebody that wants a step-by-step process, the first step is to convert to moles. Change the grams to moles, right? And then we'll do the second step in a second. So 9.75 grams is hydrogen. I'm going to change that. 1 mole. Hydrogen is 1.01 grams. And then it says the rest is oxygen. So we're doing it from 100. So we can do 100 minus 38.7 plus 9.75. And that's going to get us 51.55. So 51.55 grams. The rest is oxygen. Okay, so again, the first step is to change the moles. All right, so let's calculate these real quick. So 38.7 divided by 12.01, and that's going to give us 3.22. Let's do 2 decimal places this time. I'm getting lazy. Okay, 9.75 divided by 1.01, 9.65. Okay, and then 51.55 divided by 16. Okay, I just put times, so let me do that again. 51.55 divided by 16 is 3.22. Okay, so let's see. Do you guys remember the next step? All right, so the next step is so that we can compare between the two, all right, or between the 3 here. So we got to divide by the smallest. So we're going to divide them all by 3.22. So obviously that's 1. Divide that by 3.22. We're going to get 3. You can check it, but I'm pretty sure it's 3. And divide this by 3.22. It's going to be 1. So our empirical formula then, by the way, did you notice the order I put it in last time? Typically the formula order is CHON. I know we haven't had nitrogen yet, but that's the order that it goes in. Carbon, hydrogen, oxygen, nitrogen. So try to put it in that order when you get these formulas. So we have carbon, our carbon is 1, our hydrogen is 3, and our oxygen is 1. So this is our empirical formula. Okay, so our first step was to change the moles. Our second step was to divide them all by the lowest number of moles. And then the next step is that gives you the empirical formula. Now, at this point, since we want the molecular formula and we have the empirical, we have to use the N equals me equation, right? So we need to get the molar mass of this thing. Okay, so that's going to be, let's see, 12 plus 3 is 15, and 15 plus oxygen 16 is going to be 31, right? So 31. So we're going to use N equals the molecular, they tell us is 62.07 divided by that 31 I just got, and that's pretty much 2. Okay. And so that means our formula is going to be C2H6O2. Okay, so that's our ethylene glycol. All right, one thing I want to tell you real quick before I let you go to try example 4. So sometimes it doesn't work out and you don't get an exact, like, it's fine if you get like a 1.01 or 1.11, but what if you were to get like a 1.5? If your number here, when you divide to get the moles, I'm sorry, to get the can't think of the word I want to say. When you divide to get how many there should be, if it's not really close to a whole number, like if it's a half, seriously, if it's like 1.5, then you have to multiply all. Let's say this was 1.5, just as an example. You have to multiply all of these subscripts by 2. So this would become 3, this would become 6, and this would become 2. Okay, assuming if we were just doing it like that. Okay, and I'll try to do one like that in class if you guys remind me, because I meant to have one on here, but I didn't. So I'd like you guys to try example 4 and see if you can do it, and then maybe we can talk about it when we come back to school this week. All right, please email me or ask me if you guys have any questions when we get back. All right, bye.